Non-contact mode in AFM is the safest measurement method where the tip does not touch the sample during the AFM scan. This mode avoids damage to both the tip and sample, allowing safe and precise measurement of the sample surface topography, scan after scan. As atoms on the tip approach the atoms on the sample, a force arises that pulls them closer. This force prior to contact between the tip and sample is called the attractive force. The non-contact mode utilizes this attractive force to measure the topography of the sample without the tip making physical contact onto the sample. When the tip and sample are in close proximity, the attractive force may not be sufficient to bend the cantilever. Therefore, the resonant frequency of the cantilever is employed to detect this subtle force. In non-contact mode, the cantilever is oscillated close to its natural resonance frequency. When the tip gets closer to the sample, the attractive force increases. This increase in force causes a shift in the resonance frequency towards a lower value. This shift leads to a change in the amplitude of the cantilever's oscillation near the resonant frequency. As the tip and sample come closer, the attractive force strengthens, leading to a decrease in the amplitude of the cantilever's oscillation. Conversely, when they go farther apart, the amplitude of the oscillation increases. To scan the sample, a set point is selected for feedback control. During scanning, a feedback loop ensures a consistent tip sample distance by adjusting the Z-scanner's height to maintain a constant amplitude. The changes in amplitude are monitored and the Z-scanner is raised or lowered to keep the amplitude same as the set point. At this point, the Z-scanner is raised to uphold the amplitude as the set point. Conversely, when the distance between the tip and the sample increases, the amplitude rises, prompting the Z-scanner to be lowered in order to maintain the set point. Based on the detected changes in amplitude, the Z-scanner moves up or down to maintain the set point amplitude. The map of the Z-scanner height positions created during scanning represents the sample topography. The non-contact mode scanning, where the AFM tip and sample do not physically touch, avoids blunting of the tip and damaging the sample surface. This allows for the safest and highest resolution AFM measurements scan after scan.
Before we start using AFM, we need to register it. First, turn on the computer with the password MNTL. Follow the manual, power on the XE series, which controls the laser. Then turn on the light and adjust it to the right position. Sample loading, place the sample carefully on the holder parallel to avoid touching the upper cantilever. Next, open the VimbaViewer software on your desktop. Once opened, mouse-click on Marlin F080C, turn on the microscopy. 示照 Pixel format, bare RGB. Finally, click the icon in the top left corner. Open the Accept software. The resonant frequency of the frequency sweep is confirmed to have an obvious peak, greater than 12 nanometers. Make sure the selected frequency is in the peak position. Click the Done button. Here first unlock the Z stage, turn off focus follow, and then lower the platform in the Z direction to a height of about 270 to see the cantilever. Clicking on the area above the center line means moving up and down means moving down. Areas far from the center line are fast moving, while areas near the center line are slow moving. Check focus follow, which means move the Z stage, and the microscope will move with it. Adjust the focus stage to bring the cantilever image on the left into clear focus. Now start controlling the descent of the platform to get closer to the sample. When the distance from the sample surface is far, the rapid descent. When the distance is close to the slow descent. Lower the Z stage to the visible vicinity. You can see the background lighten. After lifting the focus from the sample surface for about 50 to 100 the Z stage was lowered with the focus follow unchecked until the cantilever was exactly focused on the ZAG. Pay attention to the moving speed must be slow. Avoid cantilever hit the surface and damage. When you see a clear bottom surface, click Approach. Then adjust the focus to the cantilever. After the approach, very slowly, little by little, lift the Z stage until the Z scanner bar is filled with green. Click the frequency sweep, then click Refresh, then Done, then Approach again. Click the Input Config icon. Then check the input source in the Input Configuration window with the options shown in the figure. Here we can select what we want to detect and click Auto. For example, we can give a scanning range, 10 micrometers, and we can see the cantilever has started scanning. We can see here in the trace window that there are two curves, each representing the result of scanning in both directions, which are now not coincident. The Scan Control window allows us to set scanning parameters. First, scan size is the size of the area scanned. Offset allows us to adjust the position of the scan more finely. Rotation, adjusting the angle of scanning. For example, here we can set 30. Scan rate. Select an appropriate scan rate between 0.1 and 1 Hz. The smaller the scan rate is about sensitive, but the scan time is longer. The actual scan parameter setpoint, scan rate, Z-servo gain is organically associated with feedback. And the three parameters need to be adjusted appropriately. Make the forward and backward lines of the trace window consistent. Okay, now we can see that the two lines are overlapping, indicating that we can start scanning. Click Scan here to scan. Okay, now we have finished the scanning. We can just click Scan after end the scanning. Here, if we want to change the position and scan again, we can control the position of the sample via the XY stage. First, we need to raise the platform high enough to ensure that it will not touch the cantilever. Then we can use the XY stage to adjust to the area we want to measure. After that, we can descend again and repeat the previous scanning operation. Okay, now that we're done scanning, click Reset, select Z stage and focus. And click our origin to make the platform return to the origin for later use of the device. Once we're back at the origin, we'll lower the platform to about 270 for the next user. When the scan is complete, right-click the image and select Send to Z. Using this software, we can do some data analysis. Here we only show some basic analysis process for reference. You can learn according to the needs of your own research. To facilitate subsequent processing of the data, it is recommended that the files in the Z be saved. After all operations were completed and the platform had been reset to its home position. Remove the sample and close the door in the same way as we had placed it. Finally, power off the device and the computer.